All right, 5.1, part 2. We're starting here on interior angles. And I'll just kind of draw an example for both of these. Let's say it goes right through there. Yeah, perfect. Okay, interior angles, I'm going to do it in red. Interior angles are what's inside my polygon. Okay, those are my interior angles. My exterior angles are the angles created outside my polygon, right? So my blue angles are my exterior angles. My red angles are my interior. Basically as simple as that. Okay. Corollary to a theorem. Okay, we're erasing, we're drawing. What's corollary to a theorem? Let's figure it out, huh? A corollary to a theorem is a statement that can be proved easily using a theorem. Okay? So let's think of this. The acute angles of a right triangle are complementary. So, right, let's start with a right triangle. Let's say this is a right angle. Okay? Well, we know that all angles in this triangle have to equal 180 degrees, right? And we know that one angle is 90. So we say like x plus y is 90. Well, if we subtract 90 from both sides, we'll get x plus y is equal to 90, right? Therefore, x plus y is equal to 90 degrees. X plus y are complementary. Okay, that'd be a corollary to the triangle sum theorem. We know that x and y are complementary to, because that is a right triangle. Okay? So it's using a statement, or a statement that can be proved easily using a theorem. Here we go, moving on. Here we're classifying triangles by sides, right? When we don't have any congruent sides on a triangle, it's called a scalene triangle. When we have at least two congruent sides, look at that word there, at least two congruent sides, we have an isosceles triangle. And when we have three congruent sides, we have an equilateral triangle. So, is an equilateral triangle an isosceles triangle? Yes, it is. But an isosceles triangle is not an equilateral triangle. Right? Okay, so know the definition between those three. When we classify triangles by angles, we have an acute triangle where three angles in the triangle are less than 90 degrees, right? Acute means less than 90. We have a right triangle where one angle in the triangle is 90 degrees. We have an obtuse triangle. One angle in our triangle is bigger than 90 degrees. And we have an equiangular triangle where all three angles are congruent. Without even knowing, or without even labeling these angles, we know what those angles equal, right? Because it has to equal, the whole thing has to equal 180, right? And we have three of the same angle. We know that each angle is 60 degrees. Moving on. Here's a few theorems that are helpful to use. The sum of the measure of the interior angles of a triangle is 180 degrees. We know that. Okay. This is what we did in part 1, that the measure of the exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent, right? So angle 1, here's the angle 1 is congruent to angle B plus angle A. Corollary to the triangle sum theorem, right? This is what I just showed you. The acute angles of a right triangle are complementary. Well, the triangle sum theorem is that all angles are add up to 180 degrees. Well, the corollary to that is that the acute angles of a right triangle are complementary. I just showed that up above. Okay. In exercises 1 through 3, we have to classify the triangle by its sides and by measuring its angles. Okay. First one, PQR, this angle here, looks to be bigger than 90 degrees, so it's an obtuse. And it doesn't say the sides are it doesn't give us that any sides are equal, so it is an obtuse scalene triangle. Number 2, angle C isn't 90 degrees. There's no nothing given to us that's 90 degrees. In fact, I'd say it's smaller than 90. So again, well, actually, here we have an acute triangle. Okay, now by its sides, it doesn't give us that any two sides are congruent, so it's an acute scalene. And number 3, we know that all 3 angles are acute. Okay, but two sides are congruent, so that's what we call an isosceles triangle. I abbreviate isosceles because I'm not good at spelling, so I'm going to say an isos. Okay, it's an acute isosceles triangle. Moving on, number 4. Classify triangle ABC by its sides, then determine whether it is a right triangle. Okay, so I went into GeoGebra. I made my triangle here, made the triangle. Let's talk about its sides. Actually, no, let's talk about its angles. Okay. Just by looking at it, it looks like angle A might be right angle. We don't know yet. How do we know if it's a right angle? Well, what we have to know is that CA, okay, and BA, those lines have to be perpendicular. Okay, and what does it mean to be perpendicular? We have to have opposite reciprocals for slope, right? So our slope for our red line is down 1, 2, 3 over 1, 2, 3, so -3 over 3, which is equal to -1. The slope for our blue line is up 1, 2, 3, 4 over 1, 2, 3, 4. So 4 over 4, which equals 1. Those two, they are opposite reciprocals, so we can say, yes, it is a right triangle. Okay. Now we have to classify this triangle by its sides. So yes, this is a long problem. We have to find each side length to see if they are equal. How do we do that? Well, we have to use either two things. We can use the Pythagorean theorem, right? We can break this into two triangles here. That's a right angle. But what I find easiest, and maybe it's a little more time consuming, but it is a definite answer, is the distance formula, right? And if we have our distance formula, okay, we know that we can take any 2 points, we can take the square root of x2 minus x1, square it, and add that to y2 minus y1 and square it. Okay? Let's start with point A and point B. So point A and point B. Let's take x2, which, let's start with 9. So 9 minus 6 squared plus 3 minus 6 squared. doing quick math, 9 minus 6 is 3, and 3 squared is 9. Okay? Plus 3 minus 6 is -3, -3 squared is 9. The square root of 18 is about, I think it's about 4.4. I'll do this quick. 18 squared, 4.2. So if I go back, from A to B is 4.2. Now let's find A to C. Okay, I'm going to do this math a little bit quicker to get through this. If you need help on the distance formula, you can always ask. So from A to C, I have 6 minus 2 squared plus 6 minus 2 squared. I have 4 squared, which is 16, plus 16, and the square root of 32 is approximately 5.65. Yeah, 5.65. No, we'll say 5.66. Round up, 5.66. Okay, so that's point A to C. Yeah. 5.66. Now we need C and B. Okay, again, doing quick math here. Square root of 9 minus 2, which is 7, squared, which is 49, plus 3 minus 2, which is 1, 1 squared is 1. So the square root of 50 is not the same as the square root of 32, so the square root of 50. So we know that this is a scalene right triangle. Okay? Long problem, difficult problem, but you can do it. Okay, you can do it. Moving on. Next exercise is 5 and 6. Find the measure of the exterior angle. Okay, so if we know that these are 53 degrees, 53 degrees, we know that these added together equal angle 1. So all we have to do is add 53 plus 53. And that's equal to 106. All right. Number 6, we know that 40, angle 40, plus this angle, which is 5x plus 15, equals 8x minus 5. Okay, here's where algebra steps in. We have to solve for x. Actually, we have to find the measure of the exterior angle. So we have to find what 8x minus 5 is equal to. To do that, we have to solve for x. Okay, combined like terms, we have 40 plus 15, which is 55, plus 5x equals 8x minus 5. If we add 5 and subtract 5x, we'll get 60 is equal to 3x. And finally, we'll get x is equal to 20. Okay, we're not done. It did not ask us to solve for x. It asked us to find the exterior angle, which is what I have in red here. So if I know that x is 20, we have 8 times 20 minus 5. I have my parentheses wrong. 8 times 20 minus 5. 8 times 20 is 160. Minus 5 is 155. Okay, good. Last one, last problem. Last problem, we have a right triangle and the measure of one acute angle. Okay, so hold on, let's draw this up. We have a right triangle. I'm going to go over here. We have a right triangle. The measure of one acute angle, so let's say this one, is twice the sum. So it's 2 times something plus something of the measure of the other acute angle, so it's this one, and 30. Okay, well, we'll call this one x. Find the measure of each acute angle. Oh, okay, so we have in the right triangle, find the measure of one acute angle is twice the sum of the measure of the other acute angle, and 30. Okay, yeah. Plus x is equal to 90 degrees, right? Because we know that those two angles have to equal 90 in a right triangle. We have, if we solve for this, we get 2x plus 60 plus x is equal to 90. Add up, we get 3x is equal to 30 and x is equal to 10. Okay? So if we know that this angle is 10, we know that the other angle is 20, or sorry, if we plug this back into here, we get 40 times 2, which is 80. Which makes sense, because it has to equal 90 degrees. Okay? So that is it for 5.1.